All right, welcome everybody. We have Seth Pevarnik of Ardex Americas with us. Seth has worked for Ardex Americas in the technical service department since 1991 and is currently their director of technical services. His area of expertise includes concrete, moisture in concrete, proper substrate preparation, underlayments, toppings, and decorative applications. Seth is a regular presenter to a wide range of organizations on these topics. He is certified in substrate and subfloor inspection and substrate and subfloor preparation. He's active in several industry associations and standards organizations, including ASTM, FCICA, StarNet, Install, IICRC, our own NFCA, and ANSI. Seth is always ready to share his expertise and wealth of knowledge, and we thank him for doing so again today. And on top of it all, Seth is a nice guy, stand up, good man, so approachable and so willing to sort of just step up and share decades of wisdom. It's awesome to have you on board, Seth. So with that said, I'm going to hand over the mic to you.
Thank you very much, Chris. I appreciate the kind introduction. Thanks to you and Lee and NFCA for giving me the opportunity to present today. And most importantly, thanks for everybody that has joined us. We appreciate you taking a little time out of your schedule to learn a little bit about thick pour gypsum underlayments. So thick pour gypsum underlayments, these are the thick application gypsum products that are poured at least 3/4 of an inch and floated across floors. And in this presentation, we're going to take a look at gypsum and detail what it is. We'll try not to get too technical there, but we'll also look at why it's used and where it's used. We'll look at the application and then get into its physical properties. Ultimately, things to look for out on site and in preparation for finished flooring, and then we'll wrap things up with a little Q&A session afterwards for anybody that has any questions in relation to what was discussed today. So to kick things off, what is gypsum? So the chemical name is calcium sulfate. And there's many types of calcium sulfate. So, I mean, if you look on an SDS, a safety data sheet, and you see one of the constituents of a product and it says calcium sulfate, that is gypsum as we know it. There are different types, and I want to share some of this with you, not to get real technical and have you learn the different types of gypsum that's out there, but it is a true chemistry when it comes down to it. We have calcium sulfate dihydrate. This is natural gypsum. We have calcium sulfate anhydrate. That's also natural gypsum. It's very common for natural gypsum to be found in the earth, typically next to limestone as a part of the reaction that's happening inside the earth. We have calcium sulfate semihydrate, and this is a little bit different. We're basically creating this by taking standard calcium sulfate, half of a water molecule, and putting it in an autoclave with crazy temperatures, crazy pressures, and humidity to create a different type of gypsum to have different properties. And then on the other hand, while those are all natural type gypsum products, we have the synthetic type gypsum products. Could be a function of manufacturing hydrofluoric acid. The calcium sulfate in this process is a byproduct of the manufacturing of hydrofluoric acid. The burning of coal in power plants, flue gas desulfurization, that process, a byproduct of burning coal and the flue gas desulfurization creates a gypsum material. And both of these would be considered synthetic gypsum materials. So a variety of different types of gypsum out there in the industry, from natural, found in the earth, and manufactured, as well as byproduct type materials, as you see here. So what is gypsum? I mean, the first thing I want to say is it does get a bad rap. Unfortunately, there's been some bad floors that have been poured over the years that don't have very good integrity, and everybody associates gypsum for the most part as being a weak type material. So, in my opinion, it's true that it gets a bad rap. I want to talk to you a little bit about why it gets a bad rap as well. But a couple of things here. It gets a bad rap, number one, where it's used. Gypsum is supposed to be above grade applications. If it gets used on grade, where we're subject to ground moisture, it can deteriorate and gets a bad rap because of that. How it's used, maybe used outside of its recommendations. You end up having an end result that's not good, used outside of its own specifications, could create a negative result, getting a bad rap. And lastly, and most commonly, it's how it's mixed. Can tend to be mixed with too much sand, mixed with too much water, and the end result is a product that may not have good integrity.
Seth, and also mixed under the wrong indoor environmental conditions.
Yeah, very, very good point, Chris. Absolutely. And a lot of water in gypsum. We got to have good drying properties within the space for installation. And in a lot of cases, it gets installed in the early part of a project and it's open to the outside elements that can be contributing factors as well.
We had a project where propane heat was being used, creating a very moist, humid environment. And the gypsum got poured and the windows were left shut. And the whole thing failed. I'm not an expert in gypsum, but the ingredients separated as a result. Is that how you would see it?
Yeah, it certainly is. And that's one of my talking points here today is one of the biggest causes of issues. It'll be in a future slide is the GC closing up the building, closing up the area, and all the moisture gets into the air, and you're basically creating a greenhouse effect going on. We got to have proper drying happening, and gypsum takes some time to dry. I mean, it's typically a week for floor covering, at least from a drying standpoint, and your conditions could mean longer time than that.
That particular case was 50,000 feet, and it was literally just crumbling, chunks of it coming up. Horrible situation.
Yeah.
So, yeah.
Yep, not good, not good. But I do want to stress to everybody that gypsum is a highly engineered material. I told you about the different types of natural, different types of synthetic. There's a variety of different types of gypsum out there. Some that are used for fast setting or moderate setting materials. Some used for short working time, long working time. Some for high early strength. Some for high ultimate strength. And some are more suited for bag products as well. So when you really talk to the chemist, the R&D chemist, when they're designing a product, they got to detail what they want that product to achieve, and then they start with a handful of different types of gypsum materials based on what they need out of that product that they're designing. Does anybody know that there is gypsum in Portland cement? Well, there is.
We do now.
We do now. And the reason that it's in there is to regulate set. So there's a small amount of gypsum in Portland cement, and it's to help regulate set, make a consistent set. A little piece of trivia for you guys. Gypsum is also a part of hydraulic cement formulation. So the industry definition of hydraulic cement is basically something that is curing chemically, mixed with water, curing chemically, and it has the ability to set underwater. So your patching and leveling materials out there that are used to prepare floors for finished flooring are qualified as hydraulic cements. I'm not saying you're supposed to use them in underwater applications, but by definition, if they can chemically react and set underwater, then they're called a hydraulic cement. All these products are hydraulic cements, and it's typical for a small amount of gypsum to be used in in these hydraulic cement formulations. You might have a Portland cement material or calcium aluminate cement material as the main binder. And there might be, you look at an SDS and you may see a small amount of calcium sulfate in there. It's not necessarily a filler, but it's a part of the chemistry of the cement. And that's where the R&D chemists come into play with taking different types of cement and making products. So just because you see calcium sulfate on an SDS, doesn't necessarily mean there's something negative about that product. So why is thick pour gypsum used? Number one, very commonly fire-rated assemblies. Similar to drywall, and in drywall, gypsum wallboard, as it's called, is basically gypsum in between two pieces of paper. That type of material used on the floor is very good from a fire-rated standpoint. And very common, the manufacturers of these thick pour gypsums have their products tested in different fire-rated assemblies for that type of application. Just one example here, but there's many different, and it's very common used as under a wooden subfloor, or I'm sorry, used on top of a wooden subfloor as a part of a wooden subfloor to achieve a certain fire rating, maybe a 1-hour fire assembly like I'm showing on the screen here.
Seth, what range
Yes.
of dimension is thick pour making reference to? Like 1.5 to 2 inches, or?
Not very, very common. They will test that their minimum thickness for these thick pour gypsum is very commonly 3/4 of an inch. So they will typically test at 3/4 of an inch as a part of an assembly because that's their minimum thickness. Is that what you
Right.
were asking, Chris?
Well, in general, you've like the title of this presentation is thick pour gypsum, and thick doesn't quantify anything, does it? So what do you mean by thick? How thick, or
Yeah.
how?
So typical self-leveling underlayments are typically poured maybe an 1/8 inch to a 1/4 inch to create a smooth floor. The thick pour gypsum is a minimum over the whole floor, a minimum of 3/4 of an inch. The reality is they're probably poured anywhere from 3/4 up to 1.5 inches, and sometimes deeper, all depending on the flatness of the floor and the substrate that they're going over. But when I say thick pour, it's minimum 3/4 of an inch. These types of products, these types of gypsum materials, quite frankly, can't perform at a 1/2 inch or a 1/4 inch or an 1/8 inch or a feathered edge. It's a minimum 3/4 over the whole floor.
Yeah, so you don't get skim coat gypsum material.
Not these types of products, which are basically gypsum in a bag where we add sand at the site and add water at the site. There are engineered materials that are self-leveling underlayments. We'll talk about that in a future slide here that are engineered, have a lot of powdered polymers in there to increase performance and enabling those products to be poured at thinner applications, 1/8 inch, 1/4 inch, feathered edge at transitions. But traditional gypsums are referenced as the thick pour because it's a minimum 3/4 of an inch, and they're commonly poured, inch, 1.5 inches, and sometimes deeper.
Thanks.
Yep. Another reason that thick pour gypsum is used is from an acoustic and thermal insulation standpoint. Sound reduction. You get into multi-family housing. A lot of times they have a membrane that goes down on the subfloor first, and then acoustical membrane, and then thick pour gypsum is installed over top of it at a minimum of 3/4 of an inch and greater for that matter. And that type of application, that sheer mass of products, along with the acoustic or thermal insulation membrane underneath, provides added sound and insulation properties. Just something to point out here. Don't know if anybody saw that in the picture here, but this is a picture that I found. We had a nail coming through the subfloor that was going to receive a thick pour gypsum application over top of a acoustic membrane. And just wanted to point out that that nail is going to transmit sound very well. So not a good thing when it comes to sound. Another thing that thick bore gypsum is used for is in-floor hydronic tubing. That's where they come in and install hydronic tubing on a wooden subfloor, very commonly. Could be a concrete subfloor, but very commonly a wood subfloor. In this case, there was a membrane that was installed first, and then the hydronic tubing installed to the subfloor, tested first, and then the thick pour gypsum is pumped in at a very thick application. Again, thicker than 3/4 of an inch, and you got to have massive material over top of those hydronic tubes. So another common application of thick pour gypsum. Fairly cost effective for that application. Sorry about that, forgot I had that in the slide. But let's take a look at where thick pour gypsum is used. A majority of the floors that are poured with thick pour gypsum are multifamily, multi-story living, typically wooden subfloors like you see in the picture. Approximately 70% of those installations that are done with thick pour gypsum, wooden subfloor. Another application that you typically see would be precast plank. These plank are made at a manufacturing plant. They're called hollow core plank because they have hollow cores in the middle of these plank, but they're trucked to the job, installed, craned into place. Each plank, after they're dropped into place, typically has some sort of camber problem where one plank doesn't meet up perfectly with the other, and that difference they call camber. And it requires some sort of self-leveling to be poured over the whole floor at some greater depths to make a flat surface. And the thick pour gypsum is, that's one of the applications that it gets used out there. Hotel applications, you see these hollow core planks and other similar applications. And that's probably about 20% of the thick pour gypsum that gets installed out there in North America. The last one would just be concrete and commercial construction. Maybe just to round up to get to 100%. We're at about 10% of those installations, just over regular concrete as a leveling material. So kind of gives you an idea where they're commonly used, where we commonly see them. What grade level should gypsum be used? Above grade. You think of gypsum drywall, and if you have a building that gets flooded and that drywall gets soaked, things can start to grow, on the drywall, and then the water can soften the gypsum drywall. And it's kind of similar with these thick pour gypsum products. They should not be used on grade or below grade in a situation where they could be subject to excessive moisture. Has an adverse effect on the gypsum. If we do get the gypsum saturated, has a little bit of a lower pH material, and things can grow on the gypsum. So very common that these products, why you got to follow manufacturer's recommendations, but generally speaking, these products are above grade applications where we're not dealing with ground moisture coming into the installation. Application, very common that these materials are pumped. As you see in the picture, they'll come and drop a truckload of sand on the asphalt or on the concrete, and they will bring a pump, onto the site, and they'll have bagged gypsum that's trucked in, and basically it's bagged gypsum, it's sand, and it's water that's placed into a pump, and then the pump will mix that and pump it up multi-stories to float the entire floor. So the gypsum, as I said, is a bag material. And certainly from a manufacturer standpoint, these gypsum manufacturers make a very consistent material. They have a lot of different types of gypsum to choose from, as we talked about earlier, depending on what they want this type of product to be used for and what performance properties. The sand, however, as I said, truckload to the site and dumped on site, and that can be a variable. The grade of sand will vary, depending on where you're located and where they got the sand. The dryness of the sand will vary, depending on how wet or how dry it was when it was delivered to the site. And certainly if we're if Mother Nature happens to decide to throw some rain into the equation, it'll certainly change the dryness or the wetness of that sand. Different from a bagged product that already has the sand in there, where the sand is a very specific sand. So the sand that's delivered to the site is certainly a variable in the equation. Water is added to the pump hopper. The gypsum is added to the pump hopper. The sand is scooped with a front end loader very commonly, and the material is mixed and then pushed through a hose up multi-stories to the space. That's a very, very common application of pumping thick pour gypsum. You can see the bags of pure gypsum behind the guy in the picture there. You can see a bobcat there with a front end scoop. And there's different ratios depending on the size scoop that the bobcat has. You know, 1 scoop of sand equals X amount of gypsum, X amount of bags of gypsum. And then certainly there's a water ratio to get the right consistency. Just to give you an idea of what's common, this is just a short video of the gypsum application. So we have a flatbed trailer with the bags of gypsum here, and we got a pump on the end of or at the end of the trailer there, where sand and water and the bags of gypsum are broke into that hopper. You see the front end loader dumping the sand in.
Seth, how accurate do the ratios have to be?
Yeah, that I'm going to kill the video there. Just it's just kind of more of the same. But you saw the front end loader and you saw the bags of gypsum. I'm going to get into that, Chris, to answer your question here in a second. Before I get into that, Chris, because we are going to talk about the strength properties of gypsum and how to achieve those strength properties, and we'll talk a little bit about those variables that unfortunately we sometimes see on site with the contractors that are pouring the thick pour gypsum. But before we get into that, I wanted to point out that there are different applications. Let me back up. While the pumping that you saw there, is common, that's not the only way that the thick pour gypsum is pumped to the site or taken to the site. Here's another alternative here where we take those variables that I talked about out of the equation. And this is basically a ready mix batch plant for gypsum. And you don't see this very often. I have seen this in Germany where they have a batch plant where the gypsum is weighed properly. The sand is the right gradation of sand. It's weighed properly. The water's weighed and put into a truck and mixed so that we have everything that is precise. But it's certainly got to be close to the job's got to be close to the plant, because you don't have all day to work with the gypsum material. So that's one way to take variables out. And another way that we'll see that we can take variables out of the equation is an on-site silo with raw materials that are weighed out to very specific weights, so that it's the right ratios, the right amount of gypsum, the right sand, and the right amount of sand. And then that silo of the properly blended sand and gypsum is placed into a hopper where the water is added and then mixed and taken to the site. That's another option to take variables out of the equation. And then a third option of taking variables out of the equation is a very sophisticated pump. And this gets used out on sites. We've seen these where you're putting the sand into a hopper, the right sand into a hopper. You're putting the gypsum into a hopper, and then the pump itself is taking the right amount of sand by weight and the right amount of gypsum by weight and getting that blended together. And then the pump is also metering the right amount of water. So the gypsum and sand are fed into hoppers in bulk. There's screw fed and conveyors into the mixing chamber to get the right amount of gypsum and sand. And then the water is weighed as well as a part of this whole pump process to give a very specific water amount so that we achieve the right consistency of all those, I'm sorry, the right amount of those constituents so that we have a material that is in very good integrity.
Seth, I was just going to ask, does this get you a particular type of amount of PSI?
Yeah, and I have some different ratios here that we'll talk about here in a future
Okay,
slide.
good.
Yep, appreciate it. That's a good question. And actually, it's the next slide. So you were right on the money. So mix ratios, very common is a 4-to-1 ratio, sand to gypsum. Sometimes it's a 5, 6, 7-to-1. But unfortunately, by adding more sand, it's certainly more cost effective, but we take away from the strength development because we have more foreign, the sand would be the foreign material in there. The gypsum is the binder that holds everything together. So by putting more sand in there, we have less binder. The risk is we lower the strength. Okay, and we'll talk about compressive strengths and strength properties here in a slide coming up as well. It is said earlier, very common, minimum thickness. Check with the manufacturer, but these thick pour gypsum products are typically poured minimum 3/4 of an inch in thickness, and they're typically poured up to 1.5 inches or more, depending on what the site requires. So, curing and drying. So, a term that you guys have heard. We all know drying, and that's the evaporation of water. If you old school wash your clothes in a drum, and then you hang them outside on a line to dry, then they dry by the water evaporating out of it. Curing is the chemical reaction between the water and the gypsum. That's called hydration. That's a chemical reaction. So the gypsum molecule and the water molecule react together, and they change into whatever they change into. But that gypsum reacting with the water makes the gypsum develop strength. Evaporation takes time. Okay, it's very common that we're at least 7 days of evaporation before the gypsum, thick pour gypsum, is ready for flooring. But site conditions are going to control how fast or how slow drying occurs. Okay, and it's no different than anything that's being installed on a job site that has water in it. Your adhesives that you comb out, that maybe they're a pressure sensitive adhesive that have to go dry to the touch. It's no difference with those products going dry to the touch. Different site conditions are going to control that. If you have cooler temperatures, things take longer to dry. If you have warmer temperatures, things can dry quicker. If we have low humidity, things dry quicker. If we have high humidity, things take longer to dry. If we have no airflow, things take longer to dry. If we have good airflow, things dry quicker. So all of those things play into the effect of the thick pour gypsum drying. So 7 days is a rule of thumb, but I have a plus sign there because it could be more time based on site conditions. It could be more time based on thickness of the gypsum as well. Thick pour gypsum priming of the surface. Once the thick pour gypsum has been installed, cured, and dried, it's very absorbent, and it may have a little bit of a chalky feel to it. So it's very common that the manufacturers have a primer that goes on the floor first. As you see in the picture there, these are low solids acrylics or low solid latex materials, they could be around the 10% solids, something like that. But you'd have to check with the manufacturers. The point that I want to make, though, that these low solids acrylics or latexes like this, they don't create a non-porous surface. They're basically being applied to the surface to kind of equal out the absorbency of the gypsum, to allow sufficient open time of your flooring adhesive, especially for the wet set or semi-wet set materials. And it's so that basically the gypsum doesn't, draw the moisture out of the adhesive, and you have ample working time with the adhesive. So very, very common for a primer to be installed once the gypsum is cured and dry. And one thing that's very common as well, it's the typical that the GC or the flooring contractor apply the primer. The gypsum contractor, I'm not saying this is every case, but it's pretty common that the gypsum contractor will install the gypsum. You've got a week plus for that to be dry for flooring, and they typically don't come out just to put a primer down. So they leave primer behind. They provide strict instructions and guidance on how to apply. And from my experience, it was common for the GC or the flooring contractor to apply the primer. I'm not sure specifically up in the Canadian market, but some of you guys there might be able to weigh in on that, if that's true up in the Canadian market as well.
General contractor.
Gotcha.
Got a question, like if gypsum can be poured so you do not need a primer, is that correct?
The thick pour gypsums are very common. It's very common to have a primer. The engineered gypsums that we'll talk about here in a little bit, some of them require a primer, others may not require a primer. But the thick pour gypsums, the 3/4 inch and thicker products, typically do require a primer.
And a water droplet test would be what you would apply to determine whether you've got acceptable absorbency or not.
Absolutely. We'd do the 3191 water droplet test. I believe I refer to that in a future slide here.
Okay.
Or bond tests.
Well, yeah, you can certainly do matte bond test 3311 afterwards to.
That tells the truth.
Yep, absolutely. And I think I mentioned that in a future slide as well.
Okay.
Flooring contractor's responsibility to do the bond test, but not apply the primer.
Gotcha. So back to the physical properties of the gypsum, the 4-to-1 ratio, 4 parts sand, 1 part gypsum, very commonly yields, when mixed with the correct amount of water and at that correct ratio, very common, a 2,000-pound compressive strength value. Certainly if they're doing a 5-to-1, 6-to-1, 7-to-1, which tends to be more cost effective because the sand is less expensive, the end result may be lower strength values there. But the thing I want to point out, even though generally speaking a 4-to-1 yields a 2,000 compressive strength, that there are different products that the manufacturers have out there in different ratios that can achieve a 2,500, a 3,500, a 4,500 psi compressive strength gypsum. So while generally speaking, in the past, the 4-to-1 was very common, and the typical gyp that you see out there, and it still may be so present day, but there are other products out there that can be used on site as well that arrive at higher compressive strengths due to their mix design and ratios. So I just wanted to point that out.
Minimum flooring standards for resilient are 3,500 psi.
Yes, they are. For like ASTM F710.
Yes.
It's 3,000 psi.
Yes.
For ASTM F710. Ironically, the gypsum standard, which is also built by the same F06 committee, F2419. So the gyp over concrete, in that standard, it details a 3,000 psi, and in that standard, and the gypsum compression strength over a wooden subfloor is detailed at 2,000 psi. But F710, which is it's the standard, it's a standard for preparing concrete to receive resilient flooring. It also says 3,000 psi.
Good to know. I think NFCA's got 3,500.
Yeah.
So we may have to look at that as a group. So we,
And different floor covering manufacturers may have different requirements as well.
yeah. Well, we're quoting, perform in accordance with F710.
Okay.
If we're saying that, then we should align with that standard. We do on other issues within that standard. So I think we should take a look at that behind the scenes here.
Yeah.
Yep. Sounds good. Okay, so things to look for. We did what certainly was brought up, F 3191. So when you get on site and you're looking for a thick pour gypsum, I told you that these manufacturers recommend it be sealed. Very common recommendation. When you look at the top picture, the water is just drinking right in, and it just soaks right in and it's gone. The bottom picture has a primer has been applied to the surface of the gypsum, and I'm not saying that water is not going to soak in, so don't misunderstand me there. And I'm not going to say that it's not going to remain, or I'm not going to say that it's going to remain a bubble either. It could soak in and that water could dissipate. But right out of the gate, when you do the water test over a primed surface, you will see water bead like you see in the picture here. Now, over the course of the next minute, 3, 4, 5 minutes, it's possible that soaks in. We see a dark spot. The water totally seeps into where we don't have glistening water. Point I'm trying to make here is unprimed gypsum, you hit it with water, it soaks in and it's gone. A prime surface, you hit it with water, and you should expect to see a bead like you see in the picture, the bottom picture there.
One of many tests that should be performed prior to installation.
Yes, yep, excellent point. Things to look for: surface integrity. Is the surface dusty? Is the surface weak? Can you drive a screwdriver right through it up to the handle like you see in the bottom, right picture? Gypsum is supposed to have, its integrity. The products are designed to have different properties, different compressor strengths, surface hardnesses. And you get out to a site and you feel like things just don't have integrity, you got to raise the red flag, and get, have the gypsum manufacturer come out and, or the contractor come out and evaluate and do their evaluation. Raise the red flag when you see something that's chalky, dusty, weak. Raise that red flag, and then get the appropriate parties to do an evaluation of what they have at hand. Is the surface easily gouged? Does the sealer peel right off, like you're seeing here? When you're doing a matte bond test, are we just peeling the surface right off with no effort at all? You can see in the picture here the remnants of a 3311 matte bond test. The flooring, you can see the adhesive kind of right in the middle of the picture. And the adhesive was basically combed out a little wider than the size of the floor covering. To the left is where they peeled the floor covering off. And to the right, you can see that little strip of sealer that's peeling right off, and the gentleman is actually holding it in his hand. For whatever reason, there's a very, very weak surface, and the primer that was pulled off, or I'm sorry, the primer that was used to apply to the gypsum dried, and we're able to kind of peel that film off, and then you have white on the underside. Shouldn't be able to do that with a primer on the surface of any material like that. That primer should soak in, dry, and you have a film.
Is there not a standard for gypsum as in terms of this is the minimum it should ever be?
A minimum for what?
PSI. PSI.
Yeah. The gypsum standard.
Because I don't know where you'd use 2000. That just seems shy.
I'm not going to disagree with you, but that's the ASTM 2419 is the standard practice for installation of thick board gypsum. And it details in that standard. Concrete is 3000, but wooden subfloor, 2,000 is acceptable.
Wow.
I'm not saying that the flooring manufacturer is going to accept 2,000. We ultimately got to go back to what the flooring manufacturer says. But that's what the gypsum standard details. But there are other gypsum materials that achieve higher than those compressive ratings too. It depends on what was installed on the project.
Yeah, unfortunately, what happens is you get, especially if they're design build, you get a general contractor talking to a gypsum installation company, and well, where can you save me some money? But nobody's talking to the flooring people so that they can better understand what they're attempting, and they can give them some basic knowledge as
Yep.
where to not proceed and where to proceed.
Yep.
And we run into that, boy, let me tell you, it can run into the hundreds of thousands of dollars.
I don't disagree. I've seen
Yeah.
a lot of weak material that did not have to be weak. It was installation related situation. And I can tell you that the gypsum that is manufactured is an engineered material, and with the right amount of water and with the proper sand and right amount of sand, can achieves the published strength values of that product. But too often we see, not on an everyday basis, but we do see things get overwatered on site, or too much sand, things like that. And there's other
No
sites.
different than concrete,
Yep. Oh yeah, you're
right?
right. Absolutely right.
Right.
We see it on the concrete as well. It's a great point. Yep. A lot of times a concrete contractor, as much as I love them and have family that are masons that finish concrete,
Mhm.
a lot of times I see as soon as that truck shows up on site, somebody wants to throw the hose in the back of the truck and give it more water so it's easier to place. And they then start ruining the integrity of the concrete. Things to look for: can't get the gypsum to dry out. It's like, come on, what are we doing with a torch? But we really got to look at site conditions. And I touched on this a little earlier. Drying depends on, your temperature, humidity, and airflow. That's the three things, regardless of what material it is. If it's a flooring adhesive that has to go dry to the touch for a pressure sensitive install, the drying of that flooring adhesive depends on temperature, humidity, and airflow. And with gypsum that has a lot of water in it, that while there is chemistry and hydration that happens, that water has to evaporate out. And to get it to dry, we have to have good temperature. We have to have good ambient humidity. We have to have good airflow. If we're sitting at cooler temperatures and high humidity and no airflow, nothing's going to dry. And that unfortunately happens on site because we don't have good conditions. To confirm dryness, an industry standard is ASTM D4263. And I'm not saying that this is a suitable test for on concrete that's on ground to validate to put flooring down, but from an evaluation to see if a specific product is dry, it's suitable for that. So mat testing, basically throwing a piece of plastic down 24 by 24, letting it go 24 hours, making sure we don't have a dark spot underneath there. And that's only for mixed water. I'm not talking substrate moisture whatsoever. This is only mixed water that I'm referencing here. And I mentioned this a little earlier too. One of the huge problems is the GC closing up the building after they pour, and they basically create a greenhouse effect, and you basically get to 100% humidity, and it's probably raining. You got water going down the windows and raining from the moisture that's collecting on the ceiling, for that matter. So we can't close the building up. We gotta have good airflow going. Good temperatures are critical as well. Another thing to look for, maybe it's a renovation and you're coming in and finding just a mud cracked gypsum floor. In some cases, it's best just to shovel everything out and start all over again. We've seen that, whoops, sorry about that. We've seen that before. So you gotta do your evaluation to see what kind of integrity we're looking at. To give you an idea of overwatering, this is an easy way to do a physical evaluation of any of these type products, whether it's a thick pour gypsum material, whether it's a self-leveling underlayment material, pick a manufacturer. But these liquid materials, and I say liquid because they're very flowable during placement, and then they chemically cure to develop strength. But the idea is having the right amount of water to make the material flowable, but not too much water to cause phase separation. And phase separation is what we're seeing in this picture, where all the heavy materials like the sand fall to the bottom and all the lighter materials, float to the top. And we're left with a very weak surface. This is a cross section of a thick pour gypsum that was, quite frankly, simply overwatered. And you got the sand aggregate fell out of suspension. It's down at the bottom, and you have no aggregate at the top, and you have a really weak surface. Now, you remove that weak surface, you get down to the sand and the cement, you'll get to a hard surface. But, looking at this picture, if it was hypothetically 3/4 of an inch thick, then we need to remove 1/4 of an inch to start to get down to the hard stuff. Okay. Looking at the cross section of any type of pourable product like this, we should see sand top, middle, and bottom. And you can see that with the naked eye. And if you're having trouble, you can just get like a little 10 power magnifying glass and look at the cross section and see that the sand is evenly distributed top, middle, bottom. But anytime there's a concern, even with self-leveling underlayments, get the manufacturer involved to let them evaluate their material and confirm the cause for the condition and make a recommendation for remediation.
That's a great slide.
Yep.
Really sums it up.
It does. And we see that all too often, unfortunately. It's not the gypsum's fault. That's why I say gypsum gets a bad rap. It's engineered, it's an engineered material, and when mixed with the right amount of sand, the right amount of water, you have a good material. But what we see here in this picture is we see it all too often on job sites, unfortunately. We mentioned, somebody brought this up earlier. I thought I had it in here. A great practice, not just on thick pour gypsum, but really on any project, whether you're going over concrete, going over patching material, leveling material, thick pour gypsum. Most all of your flooring manufacturers will recommend conducting matte bond tests. We built an ASTM standard and released it a couple of years back, ASTM F3311. Basically, what you're doing here is you're taking a 2x2 piece of flooring and you're adhering it, preparing the substrate, whatever it might be, combing out adhesive in accordance with manufacturer's recommendations, appropriate open time in accordance with manufacturer's recommendations, dropping the flooring in, rolling it with a 100-pound roller, taping the entire perimeter, letting it go for at least 72 hours, and then you come back and you cut a 2-inch strip. And you take a putty knife and you kind of get the flooring, you go underneath the flooring to separate the bond, and then you grab the flooring with your finger or maybe a pair of pliers, and you slowly and evenly pull it directly towards the ceiling in as best of a 90-degree angle to the substrate as possible. I know it's tough, but you slowly pull that up very consistently in a very equal, slow speed, pulling it directly up towards the ceiling, and then you evaluate the mode of failure. And with your waterborne adhesives, you should commonly see failure within the adhesive. If we're easily removing it from the substrate, then, like in this picture here, and we're seeing everything, all different kind of stuff adhere to the back of the vinyl plank, then we're not seeing the result that we should see. And we got to figure out why we're not seeing that. Was it properly prepared? Was the primer installed? All kind of things. Is it dry? Are we looking at a bunch of construction dust that's on here that didn't get mechanically removed? We try to figure out why the mode is where it is, and then figure out what we need to do to correct it. Is the surface weak because they got a little over water? Do we need to get down past the surface to get the hard material? All things that we got to figure out. But the 3311 is an excellent test to do. The mat bond test, gluing the flooring down.
Just a quick comment on that, Seth.
Yep.
This is all the tests are important, but this is the most important test of all. It's the last test you do before you start to think about maybe a mock-up or beginning installation. The reason it's the most important is you cannot comply with the ASTM F3311 unless all of the other tests are complete and have passed. And you know, when you're putting down flooring over concrete, there's 11 tests to consider. This is just one of them if you're going to get warranty in place and guaranteed success.
Yep, great point. Great point. So here's an example of the flooring mat bond test that was difficult to remove. And we're seeing cohesive failure, within the adhesive. Sometimes you get a little bit of the gypsum, but the point being here, this was gypsum that was poured correctly. It was dry, it was properly primed, and we saw a very good result, the flooring being extremely difficult to remove.
And it's very subjective.
Yeah, unfortunately it is. That's another excellent point. There's no way to quantify that. You have to have your hand calibrated every time you do the test to make sure you're pulling directly to the ceiling at a very slow and equal rate. I'm joking about calibrating your hand. The point being, though, this type of test is subjective because, it's almost how strong is the person that's doing the test? Is he pulling it the same rate as somebody else? It's a tough one. Trying to figure out ways to quantify this. Could you do some sort of fish scale that gives you values? I don't know, but
you got to see videos. You got to see videos of where there's failure, where it's easy.
Mm-hmm.
And then you got to see videos where it's medium, and then you got to see videos where it's difficult.
Yep.
And once you see a number of them, it's an aha, because it'd be like removing carpet tile. If it removes that easy, it's easy. It's a failure on, say, resilient flooring.
Yep. Yeah, and the other thing I'll add to that, it's an excellent point. The other thing that I'll add is get comfortable with doing the test directly over concrete. Get comfortable with doing the test over patching and leveling materials because you can't compare one to the other. Concrete's a structural material, typically steel trowel. The surface is super hard to the point where you're not going to pull the concrete apart. Even with your high performance adhesives like your two-component epoxies, two-component urethanes, compared to patching and leveling materials, they're just different materials. And it's still difficult to remove, but it's going to be different than doing the pull on concrete. So, get comfortable with doing multiple pulls on concrete and what to expect, and get comfortable with doing pulls on patching and leveling materials so you know what to expect because it's different.
The easy, medium, and difficult is pretty much absolutely the same, even on gypsum, because we've had a big job where we had to do the bond test, and there was an easy, there was a medium, and there was a difficult, and the owners picked the difficult, and it was a $250,000 extra, and they were not paying.
Yeah.
Yeah.
Hi, all. Just wanted to let you know we're 5 minutes to the end.
Oh,
Thank you.
Oh, good. That's all right. We're almost there. So once we do our evaluations, there are repairs that are certainly doable out there from a self-leveling and a patching standpoint. There are engineered gypsum plaster Portland self-leveling products that are designed specifically to repair the thick pour gypsum materials. They're low tension materials. They're very high strength, compressive strengths up in the around 6,000, and it provides new substrate to put flooring down. Skim coating products, you may see in data sheets that the skim coating product could be used over a gypsum material, but I want you to keep a couple things in mind here. You know, number one, the skim coating products, they're low tension because they're applied very thin, and you don't have enough material there to really cure and create any tension. But the thing that I want you to keep in mind here is that we are only putting a skim coat down. We're only putting enough material to give the new adhesive something with good integrity to adhere to. Okay, we haven't changed the fact that that a weaker material may lie below, and you've got to take into account any type of point load indentation that could occur, rolling loads, which would equate to rutting. You know, different than if you're pouring a self-leveling quarter an inch over the whole floor. Now we got a quarter inch hard shell material over a thick pour gypsum that may not have the strength needed for the installation. So having that quarter inch hard shell allows everything to perform. Having a skim coat could be still subjected to point load indentation and rolling load rutting. Does that make sense? Okay. So when we're installing patching or leveling materials over gypsum, double priming, very common with an acrylic primer. This helps consolidate the surface. It certainly acts as a sealer so that the gypsum isn't sucking water out of the patch or the leveling material. But without getting too terribly technical, it creates an isolation layer if a Portland cement product is used on top. So while I said that Portland cement itself has a little teeny bit of gypsum to help regulate set, if we have a pure gypsum material and we have a pure Portland cement material that are interfaced with each other, the chemical reaction of the Portland cement with the water molecule can have an adverse reaction with the existing gypsum and create what they call ettringite. And it creates a little bit of a stress right at the surface that can cause failure right at the surface. So it's very critical to have a double prime with an acrylic type primer that creates that isolation layer between the new patching or leveling material and the existing gypsum. But check with your manufacturers on their recommendations. I just wanted to point that out to everybody. Bottom line here, couple of things. Thick pour gypsum is an engineered material, and when done right, reaches the design properties, you know, of the product. But all too often, we may not necessarily see that on site, and it ends up being an installation-related situation. So just be thorough with your evaluation as you do when you're going over concrete or going over patching or leveling materials. That's the bottom line here. Be thorough with the evaluation with everything we talked about here.
Great. Thank you, Seth. Got a couple of questions here for you.
Yep.
This is from Andrew Weeb. Do gypsum subfloors deteriorate if exposed to moisture years after installation? They've had a few insurance replacements due to plumbing leaks, etc., where the gypsum became extremely brittle and required replacement, even though it seemed good at the original installation a number of years previously.
Yeah, they certainly can. It's just kind of like gypsum drywall too. The gypsum drywall is doing fine for years until you get a flood, and you know it gets wet with water and it can soften and things start to grow on it. So yeah, that broken pipe can cause issues. I would expect a softening. It could when it dries out, it could make it, I guess, a little bit brittle as well, but it certainly can be affected by water.
Primer doesn't help?
Primer can help. I mean, if we had enough primer that would stop the gypsum from getting wet, yes. But if there was a leak that we knew happened, and the gypsum was performing for years, and now we have these issues, what I would do is get the manufacturer involved and let them weigh in on what to do from a next step standpoint.
I guess assume that your gypsum will have changed and might need where the flood occurred.
Very possible, yep.
Very good. John Lupel asks, this is regarding the ASTM F3311 bond test and the wait time. Has ASTM changed things from the what has been the case for a number of years, 72 hours, 3 days, to now having to wait 120 hours, 5 days? Do you know anything of that?
I don't, and I'm on the F6 committee. But I can certainly check in to see if there's some discussions there.
There are
Right.
some manufacturers who call for 5 days as opposed to 3 days. They're not quoting the ASTM at that point. They're just saying leave it longer, but yeah.
Maybe some manufacturers, some flooring and adhesive manufacturers may, with their own products, call for longer cure and dry times. I'm not aware of anything with a standard, but I'll certainly check in. Just because I'm on the committee doesn't mean I know everything that's going on. Maybe some talks are happening there that I'm not aware of.
All right. Any other questions? Nope.
I would like to take the time just to thank everybody for taking some time out of their day. Got some great dialogue going on here today. Hopefully this was helpful. Chris, Lee, thank you very much for giving me the opportunity to present today. I always enjoy these kind of things. If anything comes up, you guys can reach out to Chris or Lee. They can get a message to me. You can reach out to me directly. I have no issue, but I'm always willing to help any way I can.
Fantastic. Thanks, Seth, for giving up your time, your valuable time. We know you're very, very busy, always willing to share your knowledge, which is awesome. Great benefit to the industry.
I'm going to close the recording now. I'm sorry. 1 second.